Year 10. Today we are going to be adding and subtracting surds, but before we do that, let's quickly review how to simplify surds from last lesson. So question 1, simplify 3 root 147 over 14. Now, 147, we need to find a perfect square number that can go into that. So what you want to do is check a few perfect square numbers, and 147 does divide by 49. So we're going to split the surd. The 3 will stay at the front. 147 is the same as square root of 49 times square root of 3. Then we square root the 49 to get 7 and times it with the 3. Oops, sorry, that should all be over 14. Times the 7 with the 3 to be 21 root 3 over 14. Finally, the 21 and 14 at the front, we can divide by 7 to get a 3 and 2. So my final simplified answer is 3 root 3 over 2. Question 2, simplify square root of 45 over square root of 72. Okay, so this was the one where we could have a couple of different options. We could simplify the 45 over 72, and that gives us 5 over 8. I think either way we do this, we're going to have a surd on the bottom, so let's go with that way. Let's simplify the fraction down to be square root of 5 over 8. Then we split the surd apart to be square root of 5 on the top over square root of 8 on the bottom. The square root of 8 on the bottom can be split apart to be root 4 times root 2. And the square root of 4 is 2, so we have root 5 over 2 root 2. Now, ideally, after we have done our rationalising section, we would rationalise the denominator of that fraction. Moving on to our new work, adding and subtracting. Now, when adding and subtracting surds, it's a lot like working with algebra. You can only add like surds. Like surds meaning you can do root 2's with root 2's and root 3's with root 3's, but you can't mix the two types together. But sometimes some surds need to be simplified before you can add them together. So if you look at part D here, a root 8 and a root 2 are not currently like surds, but I can simplify the root 8 and then maybe they will become like surds. Okay, let's start back at question 1a. 5 root 2 plus 3 root 2, because they both have root 2's on them, we add the numbers out the front. 5 plus 3 is 8 root 2's. So it's like saying 5x plus 3x is 8x. 5 root 2 plus 3 root 2 is 8 root 2's. In part B, we have two different types of surds. We have root 3's that can go together, and we have root 2's that can go together. So starting with the yellow ones, which were the root 3's, we have 2 plus 5 makes 7 root 3. And then moving on to the root 2's, we have 3 take away 6, which is negative 3 root 2. Do not try to put those two terms together because they are not like surds. So that is the answer, we're finished. Part C, we have a root 3 and a root 2, so they're not like surds. The only thing that are like terms in here are the constants. So unfortunately, I can't do anything with the 5 root 3, and I can't do anything with the positive root 2. All I can do is go minus 7 plus 2, which makes negative 5. All right, part D, square root of 8 plus 3 root 2. So it's tempting to go, they are not like surds, so I can't do anything. But I need to simplify the square root of 8. Simplifying square root of 8, we can break that apart to be 4 times 2. And then I'm going to add the 3 root 2 on the end. The square root of 4 is 2, so it'll be 2 root 2 plus 3 root 2. Adding the like surds together, because they're both root 2's now, 2 plus 3 makes 5 root 2's. Let's do a few more of those, E and F. So I need to go through and simplify each surd. So starting with 20. 20 could be split apart to be 4 times 5. Okay, then I have the minus 2, and now I'm looking at the 45. What perfect square can I take out of 45? The answer is 9. It's 9 times 5. And then the square root of 5 on the end, there's no perfect square that's going to go into that, so it's just going to stay sitting on the end. Now let's go through and work on these perfect squares. So the square root of 4 is 2 times the 2 with the 3 to get 6 root 5. Moving on to the next term, the square root of 9 is 3 times 2 is negative 6 root 5. Then the plus root 5 on the end. 6 root 5, take away 6 root 5 is nothing. They cancel out, that's 0. So there's just the one little root 5 sitting on the end. F, going through and simplifying all the square roots. So we leave the 3. 27 can be split apart to be 9 times 3. Then minus 4, 12 can be split to be 4 times 3. And 8 can be split to be 4 times 2. And the last term on the end is 11 root 3. Root 3 is not going to get any smaller, so it's sitting on the end. Now let's go through and deal with the perfect squares. So the square root of 9 is 3. Multiply the 3 with the 3 out the front. 3 times 3 makes 9 root 3. On to the next term. The square root of 4 is 2. 2 times the 4 makes negative 8 root 3. Then plus square root of 4 is 2, so it's 2 root 2, and then plus 11 root 3 sitting on the end. So we have root 3's, and root 3's, and then the 1 root 2 that's different. So putting the root 3 terms together, 9 take away 8 is 1, plus 11 makes 12 root 3's, and then the plus 2 root 2 will sit on the end. Okay, over the page to question 2. We are now simplifying fractions that involve surds. So the rules for fractions still apply. If I want to add fractions together, I want to times the bottom numbers together to get 12. And then timesing diagonally, I would get 3 times root 5, which is 3 root 5, plus 4 times root 5, which is 4 root 5. Now the top of that fraction I have like surds. 3 plus 4 makes 7 root 5 over 12. Check to see if there's any simplifying that can be done, like if 7 and 12 could simplify down, but they can't, so that's my answer. Let's do that again for part B. If I want to subtract these fractions, I need a common denominator. 5 times 2 is 10. Then, to fix the numerators, the 2 has to times with the top of the first fraction. 2 times 2 makes 4 square root 75. Then minus 5 times 3 is 15 root 3. Okay, so they're not like surds, but 75 can be simplified. So let's simplify our surd. 75 is 25 times 3. Leave everything else in there while we simplify our surd down. Square root of 25 is 5. Multiply that with the 4. 5 times 4 is 20. Root 3 minus 15 root 3 all over 10. So by simplifying, my surds on the top are now like terms. 20 take away 15 is 5 root 3 over 10. And even though I've done so much already, the 5 and the 10 can be simplified. Dividing by 5, I would get a 1 and a 2, so that my final answer would be 1 root 3, or just root 3 over 2. Okay, one more question, which we'll put a star next to for this being the challenge question. Find the perimeter of the following triangle in simplest exact form. So we did one similar to this in the last question where we were just finding the hypotenuse. So we're going to start the same way. The hypotenuse is this one here. The hypotenuse can be found using the formula h equals the square root of a squared plus b squared. Now my two shorter sides are root 2, so it would be root 2 squared plus, the other one was root 8, so root 8 squared. Simplifying that, the squareds undo the square roots. So root 2 squared is just 2 plus 8. 2 plus 8 means root 10. Again, you could use your calculator if you needed to help you with the underneath of that square root sign. This is not the end of the question though. The question asked for the perimeter. So perimeter is going to be equal to all the sides of that triangle added together, which is root 2 plus root 8 plus the root 10. Are we done yet? And the answer is still no, because the square root of 8 can be simplified. So I want to simplify my surds as much as possible. The root 2 stays. Square root of 8 is root 4 times root 2 and plus the root 10. The square root of 4 is 2, so I have root 2 plus 2 root 2 plus root 10. And now I have made some like surds. Root 2 plus 2 root 2 makes 3 root 2 plus root 10, and that would be in centimetres for the perimeter of the triangle. Okay, time for you to do exercise 4B.